So we are now in the bones of the pelvic limb. So this is most likely the sixth laboratory, no, not lab, sixth topic for our lecture. So the breakdown, so the bones of the pelvic limb are composed of the os coxae, the femur, the pes, and then the tarsus. So we have, starting with the os coxae, it's composed of 4 bones. We have the ilium, spelled as I-L-I-U-M. There's another ilium, which is actually a segment of the, intestines, and it's usually spelled as I-L-E-U-M. So not to confuse anyone. Then we have the ischium. Then we have the pubis, and the fourth one, which is just recently discovered, is the acetabular bone. So this is how it looks like. So the ilium is this one. So majority of the os coxae is composed of the ilium. The ischium is the caudal area. The pubis, on the other hand, serves as the floor of the pelvic bone. And the acetabulum is right here, right in the middle of the acetabular fossa. So all of the 4 bones will meet in the acetabulum or the acetabular fossa. Then we have the femur, the crus, we have the tibia and the fibula, sesamoid bones, which is composed of the patella and fibulae, and then we have the pes. So tarsals, tarsus, metatarsals, and digits. So I forgot to mention the crus. Then we have the os coxae. So again, ilium is the largest and the most cranial of the 4. So parts. So this is the wings of the ilium, the cranially nearly sagittal part of the ilium that is laterally concave. So it's concave on the lateral portion. Body is the narrow, more irregular caudal part that expands caudally that forms the cranial 2/5 of the acetabulum. Iliac crest. It is composed of the tuber sacrale and tuber coxae and forms the cranial border of the ilium between the 2 tubera. Caudal dorsal iliac spine and eminent on the iliac crest located dorsal to the iliosacral joint between the thick parts. So you have here. This is the tuber sacrale over here, which is the dorsal portion, and the tuber coxae is the ventral portion. So the cranial dorsal iliac spine is this one, and we also have the caudal dorsal iliac spine, which is composed of the tuber sacrale. We also have the cranial dorsal iliac spine, tuber sacrale, alar spine, a small eminence on the thin ventral border, approximately 1 centimeter, caudal to the cranial ventral iliac spine. And we also have greater sciatic notch, which is a concavity located caudal to the tuber sacrale and on the dorsal border of the body of the ilium. So it's actually, this is a greater sciatic notch over here. Tuber coxae, composed of the cranial iliac spine and the adjacent lateroventral projection of the wings of the ilium. Ischiatic spine, a slight convexity dorsal to the acetabulum that is found on the dorsal border of the body of the ilium and the dorsal border of the ischium. So this is ischiatic spine over here. So part of it is already with the ilium, although it's ischiatic spine. And then we have the gluteal surface, which is the whole external surface of the bone found on the wings of lateral, slightly dorsal parts of the wings of the ilium. And this serves as the origin of the gluteal muscles, which you will later find out in when we discuss the laboratory for muscles. Then we have the sacropelvic surface found in the wings of the ilium, and this one articulates with the wings of the sacrum by synchondrosis. So remember synchondrosis because on the next chapter, we're going to have arthrology or the study of joints. And then we have the iliac tuberosity, a rough protruding eminence in the sacropelvic surface located dorsal to the auricular surface. Then we have oscoxae ischium. So this is the caudal third of the oscoxae, and this consists of the body, ramus, stable, and tuberosity. So this is your ischium. Over here, this is the ischium. Because this one over here is the pubis. This one is the ischium. You have the sciatic arc, the sciatic tuberosity. You have also the sciatic table, this one over here. So the body of the ischium is cranial part lateral to the obturator foramen. So this is the obturator foramen. So this is the body of the ilium. This one, lateral to the obturator foramen. The sciatic spine found on the dorsal border, which is slightly concave. They also have a lesser sciatic notch, which is converted into a large opening by the sacrotuberous ligament, which is in live animals. Ramus, located medial to the obturator foramen and is continuously caudally with the ischium. And then we have the ischiatic symphysis, medial border of the ramus. Sorry. So this is the ischiatic symphysis. We also have the pubic symphysis over here. So this is the ischiatic symphysis, and this is the ramus over here. So it's on the medial part of the obturator foramen. Sciatic symphysis, sciatic table, largest component of the ischium and curve on its dorsomedial aspect, dorsolateral aspect, faces medially. The sciatic arc, border of the sciatic table, and the sciatic tuberosity, which is a caudolateral part of the ischium that is caudolateral to the sciatic table and lateral to the sciatic arc. So it's caudolateral to the sciatic table and lateral to the sciatic arc. So this is the sciatic tuberosity, and this is the sciatic table. So it's caudolateral, and it's also lateral to the sciatic arc. So this is the sciatic arc. So it's actually lateral. So why that gradually thickens from the medial to the lateral side, where it ends in a pronounced rough protuberance. The caudal end of the sacrotuberous ligament attaches to the dorsal surface of this part. And the bicep or the hamstring group, which composes of the biceps femoris, semitendinosus, and semimembranosus, originate from this one. And the sciatic tuberosity serves as the point of the butt of your dog or any other animal rather. Oscoxae pubis. So this is the dorso-ventrally compressed curved bar of bone that extends from the ilium and ischium and laterally to the pubic symphysis. So pubis, central flat triangular part of the bone forming the craniomedial border of the obturator foramen. And then we have the iliopubic eminence, the cranial border of the cranial ramus as it joins the ilium. And we have the ventral pubic tubercle. And then we have the pecten, which is in the cranial border of the pubis stretching from the iliopubic eminence to the symphysis, also known as the ventral medial part of the terminal line. Along with the pubic tubercle, it serves as attachment for the pubic tendon and all muscles of the abdomen except for transverse abdominis are wholly or partly attached to this one. So go back here. So this is the iliopubic eminence over here, and the pecten is over here, where the two pubis will merge. So this is the pecten. This is the iliopubic eminence. On an actual oscoxae, you will see how it looks like. So it's very prominent. An acetabular bone. So this is the fourth bone. So as fetuses, the puppy's acetabular bones were separate entities, and this bone becomes incorporated and fused with the three other bones of the oscoxae 15 weeks after birth. Other distinctive parts of the oscoxae, we have the acetabulum. So it's Latin for vinegar cup, and the concavity that articulates with the head of the femur, formed by the fusion of the ilium, ischium, pubis, and the acetabular bone, and the ligament of the femoral head will attach to the fossa in the acetabulum. Obturator foramen, the large opening on the pubis, and pelvic symphysis, the junction where the left and right oscoxae meet, and it has two parts, the pubic and the ischiatic symphysis. Now we go to the femur, which happens to be the heaviest bone. Proximally, it articulates with the hip bone, forming the hip joint. And on its distal part, it articulates with the tibia and fibula and the patella to form the stifle joint. So this is the femur. So it has its head, greater trochanter. They also have a lesser trochanter. They also have a third trochanter. So this is the cranial view or the anterior view, and this is the posterior view or the caudal view. Then we have these two sesamoids over here, which you will later find out what its names are. So the parts of the femur, you have head, which is smooth process that articulates with the acetabulum, the oscoxae. Fovea capitis is a depression of the head of the femur for attachment of the round ligament of the femur. And then we have the greater trochanter, a large prominence found on the opposite side of the head, and this is the point of the hip. And then we have the lesser trochanter, the prominence found on the distal part of the head. So as I've mentioned, so you have here the head, also here the head, and this is the greater trochanter, and this is the greater trochanter, and this is the lesser trochanter. And right below the head, you have the lesser trochanter. You also have a third trochanter, which is just distal to the greater trochanter. Third trochanter. You also have a trochanteric fossa, by the way. Now, the trochanteric fossa has a significance. When we do biopsy, especially for suspecting, for example, in humans, if a person is suspected for leukemia and bone marrow biopsy is needed, this is where they will get samples from the bone marrow via the trochanteric fossa, because the trochanteric fossa is exposed when you're going to cross your legs when you're sitting. Also for puppies, we can do intraosseous fluid replacements. We're going to give fluids to them via the bone. So we use this also, and we'll cross their legs. Because by crossing the legs, some ligaments and even nerves and even some blood vessels are actually being displaced. So this is actually it's easy to puncture already. Just something that you need to know. Here's the fovea capitis. It's a very shallow depression where the round ligament will be attached to. Then we have the condyles. These are Greek for knuckles, so that has medial and lateral condyles, and these prominence articulate with the tibia and the menisci, which is part of a certain type of joint, which we'll later find out. Femoral trochlea, Latin for pulley, and it has two grooves articulating with the patella bounded by two ridges. and medial one is usually the thicker one. So you will find out which one is the medial one, which one is thicker. Tibia or the shin bone. So this is medial locating long crucial bone. So this is the tibia and this is the fibula. So between the two, which do you think is weight bearing? Yes, it's the tibia. And your fibula will serve as for muscle attachment. So these are the parts of the tibia and the fibula, which you will later know in detail when we go to the lab. So the tibia also has condyles, which also articulates with the corresponding femoral condyle and the meniscus or the menisci. We have tibial tuberosity, so large proximal cranial process where the muscles and the patellar ligaments are attached. So this is actually a back view. Okay, this is the front view or the anterior view or the cranial view. So this is the tibial tuberosity. Fibula or the calf bone, so Latin for pin or skewer, and it's thin and long bone wearing little weight and serves as attachment for the gastrocnemius. So you're in Bisaya, we call it the bagtak. So that's the bagtak. That muscle is gastrocnemius and it's firmly attached to the fibula. And it also articulates with the tibia and the fibular tarsal bone on its distal end. So the parts of the fibula, you have the lateral malleolus. So carnivores have separate tibia and fibula. Both bones are separated by the interosseous space. Now we go to the patella, also known as the kneecap, and this is the largest of the sesamoid bones. Oval or ovate in shape and curve. The curvature allows the bones to articulate with the trochlea of the femur, and this is the ossification in the tendon of insertion for the large extensor muscles of the stifle joint, which is the quadriceps femoris muscle, or we call it simply as the quads. Parts of the patella, so they have a base, apex, and articular surface. So what are the functions of the patella? They alter the pull of the tendon of the quadriceps, they protect the tendon, and provides a greater bearing surface for the tendon to play on the trochlea of the femur than would be without that would be impossible without it. Fabulae. This is Latin for little bean, and these are two sesamoid bones found on above the condyles, and these are only present in our carnivores. So here we go. These are the two sesamoids that I was talking about. So this is the patella, and this is the patella. So this is a dorsoventral view, and this is the lateral view of an X-ray or a radiograph. And at the back, so this is your condyles that I've mentioned. These are the fabulae. Again, this is the fabulae. This is the trochlea, by the way. So that's the fabulae superimposed. Now we go to the tarsus or hock. So Greek for tarsus, which means flat. For dogs, they have 7, pretty much like the carpals. They also have 7 carpal bones. And they're divided into 2 rows, similar to their carpal counterparts, the proximal and distal. The proximal row consists of the tibial tarsal and the fibular tarsal bones, and the distal row consist of the central, first, second, third, and fourth tarsal bones. So the tibial tarsal bone, we have the talus, also known as the ankle bone, and this is the largest of the tarsus, and this is dorsomedially located, and it articulates with the trochlea with the tibia and fibula in dogs. Then we have the calcaneus or the tibia or the fibular tarsal bone. So the calcaneus is also known as the fibular tarsal bone, also known as the heel bone, found lateral to the tibial tarsal bone, and it has a very prominent feature called the calcanean tuberosity, which is the large process of the fibular tarsal bone, which serves as a lever arm for the common calcanean tendon. Now, what is the other term for the common calcanean tendon? Again, what is the common term for the common calcanean tendon? Which is the other term. So this is how it looks like. So we have here the talus, which is located on the medial part, and this is the calcaneus. So this is how big it is. And then we have the central tarsal bone, and these are the other ones. So the counting would be from medial going to lateral. So we have, this is the central, and then 2, 3, and 4. Metatarsal and phalanges, so same pattern as that of the forelimbs, except for the number of metatarsals present. So for dogs, their metatarsals are actually 4, not 5 that is present in the notes. So kindly change that information. So instead of 5, change it to 4. So if they have an extra claw, if they do have 5, it is required to have them cut or amputated. You can have them amputated for as early as when they are on the first week of life. It's easier and less bloodier. If it's beyond that, it's more painful for the dog. At the same time, the bones are already very hard. It's very hard to cut or amputate them. A lot of vets would have this one amputated because it's first and foremost, dogs don't have awareness on their hind legs. So it's most likely going to catch on like a barbed wire in the back. So there's that safety issue with that. There's also the problem of not having their having this trimmed because it's too short. It's too high. It's not short. It's too high. So some dogs don't even like to have them trimmed, and they tend to do scratching movements, right? Even right after they poop or pee. Most of the time, it's actually their hind legs or claws on their hind legs that are relatively shorter than the front legs because of their scratching motion when they do scratch right after they poop and pee. But that part, the dew claw, does not touch the ground. So there's a reason why it needs to be, it tends to grow more longer. And then for your clinical notes, we have the hip dysplasia. So hip dysplasia is quite common among large breeds of dogs since these guys tend to grow faster. So at a rate of, let's say for a Labrador Retriever, that's a large breed of dog, they can have a growth rate of 2 to 3 kilos in 2 weeks. So can you imagine their growth rate? And if it's too rapid without the proper supplementation, and also they don't have that very nice rough terrain where they can run around, it would lead to hip dysplasia. So there is either their acetabulum is too shallow, or their most of the time it's the shallow acetabulum and rapid growth for a large breed of animals. So just be very careful when you're going to do supplementations to your dogs. So if you do have any questions, please do comment, and we really appreciate questions. It will help us also with it will also help you with your learning. And on the next topic, we are in arthrology already. So I'll see you guys later.